All right, thank you for coming in the rain. It's my great pleasure to introduce Cameron McBride, who has a strong Vanderbilt connection. Cameron is an astrophysicist by training, like myself. He did his PhD at the University of Pittsburgh, and the work that he did was very cutting-edge sort of statistical analysis of large galaxy surveys, which is also my field. And he
wonder why he hired me.
his work was very sort of, I would say, some of the most technically challenging applications that people were doing. After his PhD, he came to Vanderbilt as a postdoc, and we worked together for 3 years, analyzing data from the Sloan Digital Sky Survey, which is a massive effort in astronomy that's collecting information for millions of galaxies. And then after Vanderbilt went to Harvard to do another postdoc, continuing working on next generation versions of these surveys, doing very sort of statistically intensive work, and then made a transition from academia to industry in data science, which is a very natural fit for people doing astronomy because we work on large data sets, so there's lots of problems. We do statistics, computing, and so a lot of people are actually transitioning from our field. And so he has experience both in what it's like to be an academic, a grad student, postdoc, and what it's like to be in the industry world, and has actually switched companies a few times. And so he's going to tell us about what that transition is like. Thank you.
Thank you, Andres. So what this is hopefully going to be, hi, good to be here, sorry. What I would like this talk to be is kind of a discussion, but what I really focuses on is kind of how I transition, kind of my story, and kind of some kind of lessons about what I learned and kind of some advice. So hopefully you'll get a little bit more of a sense for me and a sense for kind of what my path is, and it's not the only one that's possible. So I was talking to someone right before, I come from a technical background in physics. I think a lot of you might overlap with that from a PhD program. I did years of postdoc, but there's different stages in data science. There's lots of potential opportunities, and hopefully you get that theme throughout. But one thing I want to encourage is this is much better as a discussion. I have these things called slides. I can talk about them. That's a boring talk to me, okay? So if I have to skip slides or miss things or jump around and we're having a good discussion, I think that's much better because what I want to do is answer questions, address things. So don't hesitate to interrupt, to raise your hand or just call out or whatever else if you have a question on things or you don't understand or it's a side question, because there's no way that I can cover all of the topics that's there. And I am loud and opinionated, so I'm happy to present those opinions given the opportunity, but I'm not going to try and do that within the scope of everything going on.
Also, feel free to come up and get more pizza.
Yes. This should be as informal, as comfortable, as there. So also, may the 4th be with you, because I'm still a geeky astrophysicist at heart. That's the first thing my daughter said to me this morning. She called and said, "May the 4th be with you, Daddy." That's a point of pride. So really what I kind of did the framework of this discussion is really just an overview of what is data science, what is the definitions that I'm using kind of moving forward. Why did I choose data science obviously from my experience, and then how did my transition kind of work? So the what, why, and how of where this works and kind of my opinions and learnings throughout. So I didn't discuss the who there, so this is a little further background. Who I am, I think, is very relevant because I can only present my biased perspective. All right. So I am currently a data scientist in an applied sense in industry. I work for tech startups. I'll tell more about that later. I did a bachelor's of science and a separate bachelor's of arts because I really liked undergraduate work at Case Western. I did an astrophysics PhD at the University of Pittsburgh, and then I did postdoctoral research at 2 universities. So what you should read out of this is I worked at 4 academic institutions doing research, deep research into galaxy formation, evolution, cosmology, and using statistical and computational methods throughout. So that's kind of the background there. So my research interests included galaxy evolution and galaxy clusters, large-scale structure. This is the distribution of galaxies in the universe to understand how galaxies form and evolve, but also how mass clumps, which means dark matter, dark energy, how gravity works. And then cosmology, high-performance computing. I thrashed many NSF-funded computing centers and annoyed the crowd out of many people. I still do that today, but now they're just in industry. A lot of stuff of statistical modeling, something I didn't talk about. At the University of Pittsburgh, there's this other university that's close by, Carnegie Mellon University. There's also a Pittsburgh Supercomputing Center. So I would bug all of these. At Carnegie Mellon, there's a really great stats program. So we did some astrostats, and I worked with statisticians. So that side of things has been influenced me for a long time. And so I've actually made use of that in kind of industry. But really if I would boil it down, a lot of what I did and what Andreas does and a lot of people is kind of growing is this tight combination of, I would call myself a theorist, between data-centric theory, right? And this is a kind of a growing trend, and this is a big thing in astronomy, for those that know, is because there's a lot of data, but we can't model all the physical processes. We can't do MHD simulations, magnetohydrodynamics, right, and figure out how the magnetic field is actually impacting the gravitational dynamics. That's kind of very hard. So you're using empirical relations and kind of approximations for things and the theory side to encapsulate many physical processes, and you're applying that and trying to constrain our understanding of those using actual real data and messy, different, disparate data sets. And so that kind of is somewhere in between the two. It's a more applied theory than just writing down paper like what Bob Scher likes to do, but he does actually use data. With fiction is great. You actually write fiction too. So, but combining those two has a good sense. So I want to paint that picture because that definitely influenced where I went and moved forward. So the bulk of my academic research was spent doing this. I don't know how much it comes across. I'd look at these beautiful images of galaxies. These are big, kind of large red galaxies. I called them cosmic cotton balls in one of my classes. What you do is you look at these very complex, massive objects, and you reduce all of these down to little points that you stick in a 3D map, and you analyze the clumping of that. So in formal language, this is kind of emergent behavior that gravity kind of makes these complex structures where you see something like this massive structure known as the Sloan Great Wall, and you see these pockets that are voids, and those all depend on cosmology and other thing else. You're making basically a 3D map, taking really complex objects and making them all points, all right? So you're really reducing a whole bunch of data and just looking at one aspect of things. So that's what I did as an academic. What is data science? And I think this quote from now a very old movie really sums it up. So I don't know who's ever seen The Devil's Advocate, but obviously Al Pacino is playing the devil. And he has so many names, and data science has just a whole bunch of names that apply to that. So what is data science is a whole other thing in itself. So I'm not a huge fan of nomenclature and what specifically are things moving forward, but data science also has all these kind of things. Big data, machine learning, statistical inference, networking, you can see of them. Marketing, models, predictive analytics, descriptive analytics, statistics. All of these things are kind of data science. What I'm going to focus on is what is kind of the meaning. I feel, my personal opinion, that data science, while it exists as kind of a field, what people mean by it is dramatically different. Someone goes, this is a data scientist. Well, what they really want is someone who's a machine learning expert. This is a data scientist. That's really a software engineer, I would call. But, it doesn't really matter. So there isn't really a standard definition. And as I'll say, and kind of hopefully echo in some of the other things, data science itself, I would probably say about 80 or 90% of the jobs out there that are looking for data scientists don't know how to utilize the data scientists and actually don't even know what they're looking for. So if you're getting into this field, it's a niche that has existed for a really long time, but we have a lot more capabilities and overlap. But what people mean by that and what people want from that varies a lot. All right? So it's not this hierarchical thing of I'm going to get a master's, I'm going to understand these things, I'm going to get a PhD, I can do this route, and this is all charted before me. That doesn't exist really. It does exist. There's lots of people that think, oh, this is the chart you're going, but that might be a misuse of kind of what people are doing in data science. So I'm very much in this realm of, I think data science should interface strongly with the technical side, help guide development of things, solve impactful problems, and do kind of bringing a very basic definition, is bringing the scientific rigor that you learn in an academic program into an industry setting. And I personally think that provides a competitive advantage. So it's not like we're writing papers and we're not doing things applied. That's not what I believe. I think that this scientific rigor of using data that exists to answer questions that the CEO used to just whip out from gut feelings is a better way to do that and provides an advantage. And there's lots of structure around that where that's kind of moving. So I want to continue with the what of data science and tell you what my history is a little bit further. I gave you the academic side. So the first company after Harvard, Boston, I say, is one of these tech kind of centers, and I was like, I wanted to look for things. So I focused on, I picked a specific niche. I didn't want big companies, I didn't want a Google, I didn't want a Facebook, all right? I wanted, what I did is I really enjoyed my international collaboration with the Sloan Digital Sky Survey and working with people, which is a group of 20 or 30 people in a big science collaboration group. We're supposed to do some analysis where about 3 people actually did the work, right? And then you're a rotating cast of 1 or 2 others that provided a plot or did some writing or something else. So that's a standard practice. I was familiar with that. I wanted to represent that there. I actually liked that. It provided a collaboration and kind of an interaction that I found very favorable. I felt that tech startups also provide that collaboration. I found that out through interviewing and investigating and going through some very grueling interviews. What I really liked about it is, at the end of the day, it didn't matter what my job description was. This company relied on getting something done, right? And so you would rewrite your job description, you figure out what needed to do it. So sometimes you do system administration, sometimes I would be talking to customers. So it gave me a sense for what the business was, and I felt I could grow and learn what the niche of these things were. That was important to me. So at TrueFit, I went from analyzing galaxies to the very first project I got, I was told, ended up doing, TrueFit was this software as a service company that was using machine learning as its core, that was providing directions for fit. So you would shop online and you say, ooh, I want to buy these new jeans, I don't know what size they are, but I like Levi's in this, and True Blue jeans in these, and I'd look at these things and say, oh, this is your best fit. So my first project was, how do you make swimwear and intimates fit better with online shopping? Analyzing galaxies to making underwear and swimwear fit better. That was my jumping off point. So of course that sounds exciting, right? Yeah. For me, I worked there for 1.5 years, and I'll talk a little bit more why I worked there. The main product was applied machine learning. We were using data to try and figure out how to do things further. And the business side of this is actually very simple. People shop online, you guess there because you don't know your size, you don't buy as often, right? And that's called conversion rate, right? If you don't know it, you don't buy it. You go shop it and you only buy things that you kind of know of. So if we can increase the conversion rate, people are having more sales. That's a win, okay? That's why companies like Macy's and whatever, paid TrueFit to go on their site. The other thing is you reduce returns. They're saying free returns. That might seem great. Maybe you're not, maybe you're like me and you're not like me and you actually send your returns back. I just kind of let them sit there and be like, oh, I guess I sell that on eBay, or it fills a box somewhere. But some people actually ship them back. That's very expensive. So even if you reduce that a little bit, the net return for retailers is huge. All right? So that's kind of what I did. It was a made product, but there was a whole bunch of other analyses, like analyzing A/B tests and statistical tests to say, like, is our conversion rate up, or are we hurting the company? Or are we getting fit sizes that are actually useful? How do we actually look at that? How do we convince our customers that we're doing a service that they're paying for that's making them money, right? And the other question is why would you analyze how clothes fit when you're studying the cosmology and like the universe? To me, it was actually kind of fun because it was a completely different thing. The other thing that was really cool, it was a startup of about 30 some odd people. It was about 70 when I left. The gender balance was right down the middle because it was fashion. So that was kind of fun to actually be in a tech company, which is anomaly. So you think science and astronomy are hard with the gender balance? Yeah, go into tech. They've been declining for since the 60s. So it was kind of an interesting balance where I kind of wanted support and wanted to see a very different environment that was producing something in another industry. And I'll talk more about that in a little bit. But then I moved out of fashion or footwear and apparel and went to a different company after 1.5 years, another startup in advertising. So this is ad tech. So it was formerly a little thing called Ntoggle, a little startup of about 20 something. Ntoggle was then purchased by the company that I'm wearing now, which is Rubicon Project, and it works in ad tech. So what is ad tech? Tech is short for technology because it's all hipster and we don't say the whole words, right? So ad tech, advertising technology, Marketing technology, anyone want to guess what that is? MarTech. All right, how about financial technology? FinTech, exactly. So it's like, apparently you want to be cool and do Silicon Valley, so you just truncate words and put the letters together and make some little catchphrase. So that's a thing. So for me, advertising was not what sold this to me. Although, does anyone know the two biggest behemoths in advertising? You do. Google and Facebook. Those are the top two. That's why they're evaluation. They're doing advertising. That's it. That's what they're made for, right? Google, we were talking about this before. Google didn't even know how to monetize things when they're making a search engine and what for. But now they're a behemoth because they do advertising. Facebook, because they dig down and they know users very well, right? Google too. There's a reason that Google doesn't say we're not evil anymore, right? Probably a PR thing, but whatever. The idea there is that in ad tech, there was a whole ecosystem that kind of developed, which maybe I'll touch on in a bit, but it became a real-time problem. If you go to an ad on your phone, right, you search the New York Times and an ad pops up, okay? That ad is actually decided in milliseconds. The New York Times sends it out to an exchange, the Rubicon Project exchange. That exchange then farms out to a whole bunch of people that want to bid on that specific slot with your user ID, your IP address, potentially your GPS location. We send all of this free streaming over the internet. You've all okayed this with government, policies. All of this stuff kind of moves forward, right? This gets farmed out to maybe 10 or 100 people that can bid on it. Let's say it goes out to 100. About 10 people said they made a bid. There's an auction held to figure out which of those 10 is willing to pay the most price. There's sometimes a secondary auction held, and then that ad is placed. That happens every time, that ecosystem. That's grown over the last 15 years. The people that want to bid, they want to place their ads in places that have specific things. They're coming up with all these fancy ways to kind of, I want to bid this, I want to bid this price. So there's a whole game theory of what bids give me the right exchange or whatever else. So NToggle was a way to democratize this because it requires massive amount of computing to kind of do this. So the queries that go across in the world, I think Rubicon Project farms through about 500,000, about 500,000 queries right now. The whole world is about 6 million queries per second in peak. That's how many ads are flowing across where people are requesting ads. And so people are buying these things, right? To figure out, people want less than 1% of these, right? So the ads themselves, and they're satisfying their campaigns of ads in less than 1%. So how do you not spend 100 times more computing power than you need to process things, to figure out things that you don't want, because that's expensive. And so that optimization is what NToggle did, and it thought, and Rubicon Project wanted to kind of change its status and thing and trying to fight against Google and Facebook and everything else. And so as they were growing, what they did is purchased NToggle, which is a 23-person company, for like 38.5 million, right? Primarily for this proprietary filtering solution. So what you should learn through all of that gobbledygook is that this was a very big real-time problem that was very different. This is not astronomy data that I'm taking pictures that sits on the disk that we figure out. We have to make decisions where we have no hope of storing 6 million queries per second, which are all these JSON requests. They have all these fields. So we're just touching the iceberg. We have to make decisions in milliseconds. Right? So how do you do advanced machine learning in these type of things? How do you filter and make smart decisions? So it's a very different domain. So that's what I was doing at Rubicon Project, NToggle, and what I'm still doing. So this is just the filtering as one of the things in the slide deck we do it. So Rubicon Project is what's known as an exchange or a supply partner, because the supply is like Boston Globe and New York Times and CNN. And so they might farm out 200,000, 200,000 queries per second. And so they're sending them. You have these kind of filtering that goes down, and this is the toggling thing that what NToggle did and what they bought. And so basically it turns 200,000 into the 10,000 that this person wants. So it's making a good choice of the 10,000 from that 200,000, sending it to the DSP, and responsively changing that as they have new campaigns and everything else. And so it's kind of a funneling thing to just give you the tip of the iceberg of what you want that satisfies all of your need. Because you only want a small percentage of that, and so we maybe only want 1%, and so we send you about 5%, and that's only a factor of 5 more processing that you had to do before, right? So it allows you to effectively look at the world with less data. And so that's kind of what we're doing. And that's what you should get out of this photo. Any other questions?
So what
what was the how and the why when you moved from one company to another? Did somebody walk in a bar and tell you they wanted to give you a job, or?
Basically, something like that. I will. This is just the what. You'll finish the what, and then the how and the whys are going to come right after. So I go through the same sequence in the kind of the how and whys, a little faster though. So real quick, another old movie reference, but we're going to go through the good, bad, and ugly of kind of some of my learnings from what is data science. But I'm going to turn it around and start with the bad first because I'm a skeptical optimist. All right, and so I want to end on a good note. So the ugly, all right, coming from academia, I can only provide my opinion, all right? So there's an implicit bias in all of these things. I'm only giving you my perspective. Go out, talk to other people, get other people's perspectives if you're seriously considering this or you want to advise people that are seriously considering this. There are so many definitions of data scientists. What a data scientist is at one company or at Facebook, at LinkedIn is very different than it is at a tech company. It's very different than you have in an academic setting, and it's different than the people who are going to be teaching you data science in a classroom. Okay, so understanding what that variety is and what variety you want to group towards is actually a really key aspect. The description depends significantly on context, as just what I was saying. Right? For example, statistical significance in science. Who knows astronomy? Raise your hand. So you see a paper, 2 sigma result, 2, 3 sigma, that's pretty okay, right? This is basically statistical significance is mostly 95 or better. Right? In medical science, it's even crazier. Right? In higher G physics, what happens, does anyone know in higher G physics or particle physics, can you publish a 3 sigma result? Yeah.
Talk about it.
Yeah, yeah, it's not even, you can't even say it indicates, right? So there, right here you have one very standard, very specific definition of statistical significance that varies widely between fields. So the same thing applies here. Data science is this huge field, and what people want out of it is very different, all right? So the other thing about the real world, mentors and managers, well, they're kind of like your advisors. Sometimes you get lucky and it's a great unicorn and they're really good advisors. A lot of times they're just trying to balance things between and do other things. You might not get the guidance you really want. Your managers in the real world are not going to be a whole lot better. There's things that are different. Facebook has, or LinkedIn has this nice little structure where they kind of have this very hierarchical and they kind of train, right? But a lot of places you're not going to go, work for someone and they're going to give you the golden kind of chalice of how things are going forward. That's especially true if you're a PhD scientist where you're expected to kind of jump up at kind of a more senior level. You can't keep looking up for help. Basically, you're going to be looking up to people who understand more of the business side, and there are people who are running the company, and you can learn about that, but they're not going to tell you about like which statistical method. Oh, you use deep learning? That's fantastic. Why didn't you use logistic regression? Said no CEO ever. So there's these things that you kind of move forward where you have to kind of design your own. So if you think that's just what you had to do to finish up your PhD, guess what? So finally on the ugly, messy or insufficient data. This is one of the reasons I think astronomy is actually really good. There's also medical and everywhere else. This is all over the place. Like, we want to answer this question. Well, it's like, you can't with this data. Doesn't matter what fancy method you can cook up here, you cannot fix the data. The data broken, bad data, doesn't matter what it is, bad result, right? You can't magically, put things in place there. And so that happens all over the place. Sometimes they don't even store the right data, right? At TrueFit, there was a company that's like, we really love your product. We want to do it. It's a tech company. This is fantastic. Oh, they paid us, everything else. And they're like, well, you don't have the data that we need to make predictions for the size of your products. Or like, well, we thought you could fake it. We're like, well, that doesn't really work. Now, luckily, that was just a client, so that's a very easy thing. Like, here's your check back. Come back to us later. But, I mean, in a lot of other cases, you'll have management or a CEO or the CTO, the Chief Technology Officer, will promise this to the board or something else and be like, hey, can you fix this for us? Ouch. That's a tough one because now you've already sold it and you have to figure out where to go. And knowing that and getting ahead of that is kind of key. So the bad, also would say, this is not really science. It's called data science. I actually hate that term. It's kind of like software engineers are not engineers, data scientists are not scientists. We work together to do madness in industry. But the goal is really to help a business need. That's in the specific applied stuff that I do. It's really, what is the business need we're solving? We're not doing this for the sake of increasing knowledge. We're trying to produce something practical and tangible, right? Some impact and benefit. What's the difference from collaborators to coworkers? Well, one thing is nice. If you collaborate with people, besides your thesis advisor or some people that you have to work with, right? If you have a collaboration, it doesn't go well, you're like, I'm not going to write that second paper with them because that was absolutely horrible. all right? With coworkers, you show up to the same office, you got to work with them. Unless your boss wants to fire them, you're kind of stuck kind of working this through. You still have to produce tangible results or you have to leave your own job, right? The thing is, like, sometimes that happens. So that's a little bit, you're kind of longer and stuck with people on multiple projects. That's not always the case, but that's been kind of my experience. There's been some very good things there, right? And some things have changed, and there's some also difficult things. So just like the data, there's often ill-posed problems, again, like research. Some very interesting hard problems, but they're very ill-posed. So they want to answer question Y, you can only answer question X and Z with the data. How do you kind of move forward? How do you guide the things to do it? So one of the bad things, if you want to get away from your day-to-day job of sitting at a computer and programming and then fighting about plots with people and interpretation of things, maybe this isn't the right thing for you because you're doing that same thing with people that understand less about what you do. All right, so now we're going to go on to the good. Any questions, or kind of being very quiet? All right, the good. Notice the first point. Might look familiar. I did data science because I liked the day-to-day thing. I liked arguing about plots. Andreas and I used to have 10-minute conversations for 2.5 hours. It was awesome. That might be a function of us, though. Your research skills that you do, whether it's in astronomy, whether it's there, I think are extremely applicable. I would argue that most places, even a lean tech startup, a big company, very few places actually know how to, make them that effective. All right, I think you heard from Stitch Fix, who came like last year or talk or something recently. This is a company it was a tech startup that focused on data science around their idea. I think that's a great thing, but that's an anomaly. I don't know if they were the first, but those type of things where they're focused around that kind of data-centric view, shaping the world, is not often how it is. Those research skills of the scientific rigor of like, does this actually provide a coherent story? Can we rethink this? What assumptions are baked in? That skepticism is very useful and an exercise for everybody to do. So job cycle and grant applications. In astronomy, you apply for jobs like once a year, you get things or you don't, and you make a decision for a year. If you want to get out of that cycle, your options are very, very limited. In data science, I can now live in Boston, which I live in now, and I can change jobs and not move. That's glorious. I can decide to get a new job and probably have a new job from starting in a month or a few weeks, right? I give a 2-week notice and move on once I get a job. It's much quicker, and then things change fast, and you can adapt to those. So for me, the work-life balance went through the roof, because science and astronomy was a passion, and I would do it. I would work on weekends, I'd move forward. So I was a postdoc, I did many years of postdoc work. I had a family and some other chaos that was there, so I had life. But I went from a postdoc and switched to industry. I was a well-paid postdoc at Harvard. I doubled my salary in about half the time I was working, all right? And that's just my initial position. And that's not including equity or whatever else, just the amount of money I take home and everything else. That allowed me to have a work-life balance. I now regularly take weekends off. Like, working on the weekend is an anomaly. Now, you'll do it if necessary, work in places where there's demand and everything else. But it's like, since we are acquired, what does data science really need to do on the weekend? Sometimes I'll catch up on a Sunday or whatever else, but most of the time it's kind of easy. You still work with really smart people. So this whole idea that academia has a lock on that, there's really interesting problems, really great people to work with, all right? Which gets to the next one. There's really great and interesting challenges. From a technical point of view, there's lots of great things out there. All right, so that's the end of the good, and I'm going to move on to why. Any other questions? All right, I'm going to have to engage you guys some more. All right, why? All right, so why would you go analyzing massive cosmic sound, right? Big rings. These are baryon acoustic oscillations encapsulated in the early universe. It's cosmic sound from things collapsing. You're measuring, that distribution of how it forms galaxies, and you're measuring the distance between galaxies, which that line's supposed to do. And you're figuring out how does that relate to the underlying cosmology and everything else. Why would you leave this to do something else? I mean, cosmic sound waves are pretty cool. Also, does anyone know that movie quote in the top? I'm Mary Poppins, y'all. What?
Guardians of the Galaxy 2.
Guardians of the Galaxy 2. If you haven't seen the clip, it's a good one. Well, here's a good why. Just let that do. I think that one speaks for itself, so I don't really have to do anything there. But one thing I will say is personal life challenges. Life comes up here, right? Often people in academia, they deal with two-body problems. They go, they're not together, they go, they meet another academic. Both of you want careers in academia, and you got jobs in different countries, right? What do? Someone might have to make a concession, someone has to give up. These are real-life choices. I found things there. I had kids in grad school, right? That changed things, right? I was happy with that decision, but it also focused certain things. Like traveling was hard with kids, and it was grad school salary and then postdoc salary in expensive cities. So it was like, it's not like I'd be like, hey, wife, don't work, take care of the kids. That wasn't going to work. So those real life things impacted my choices, right? If you have a lot of opportunity, you can normalize out some of those choices. For example, I switched to industry. In data science, I chose tech. I couldn't travel as much for some personal reasons, right? I found good jobs where I didn't travel much at all, okay? I think I didn't travel for work for 2 years, okay? I've now traveled some, but I didn't have to, and I found very engaging careers doing technical stuff. Whereas if you don't travel for 2 years for work as an academic, that's also putting you in a certain class that's not going to go further. But anyways, these kind of life choices actually happen. So for me, just going back to my experience, there was lots of data, right? I'm not going to get in the whole Jedi thing of good and evil, but I mean, the thing is the world is a fascinating place. There's lots of very interesting challenges. There's a rapid pace growing in data science and what these things can move forward. There's so many applications of machine learning and these statistical methods and, possibilities to advance things with kind of scientific rigor and using data. We are collecting so much massive data. And so one of the big things is we are changing an economy, right? Our economy is based on data and information. This is at the crux of what that is and making use of that. And so that's a very interesting thing. My thesis was on three-point correlation function. I make a joke, and we were joking yesterday, there's 11 people on the planet that cared about the three-point correlation function. I knew 8 of them, and I couldn't get more than 5 of them to listen to anything I had to say. I'm pretty sure that hasn't changed since I completed my thesis. I think there's still the same 11 people, which is what we were joking about yesterday. I went to fitting online sales, right, in TrueFit. It was a $2 trillion industry. The number of people that want to buy things, the impact you have is huge. People use this for weather prediction. They use this for, which there's a startup doing, which a former astronomer is doing. They do this to, streamline their lives, to, prevent safety issues. There's so many applications to guiding our knowledge of our dividing, attention, that you can really impact a huge number of people. And then jobs and demand, that you actually have jobs and can choose things of cities that you live in to some extent. So why did I choose go ahead. No, please.
Basically, the question would be because you said that when you just joined the startup, so you get to do a lot of different. Basically, you didn't have one fixed position. You have to do a little bit of this, a little bit of that. I think that's what you said.
Yes.
You were learning a lot of different stuff. You also mentioned that data science is such a broad thing that people, when they hire you, they have a problem, but they don't know who they need.
They can be. So, I'm just saying you have to be very careful. A company often doesn't. Sometimes the person that hires does. So this is getting into the how a little bit there. But at TrueFit, the person that hired me was a former astronomer. So he knew my worth better than I knew, okay? Because I didn't have the confidence to know what those skills were. He's like, I've had a lot of luck hiring astronomers because he knew the data-centric aspect of moving forward. So he was hiring me for a specific thing that he knew about. The company itself was pretty good at supporting that, but many don't.
Yeah, but the problem here is that basically, because you said that from science side you will not find help most of the time, because you said that the supervisors, they're business people, they can just go on what type of statistical analysis I will do, I don't know. So, because they might not be good, they might not be sure, when hiring you, what exactly they need. And
Correct.
Go and there's a problem, you don't know how to solve it.
Right.
Your skills are a little bit different.
Right.
So how is it?
Well, I'm just saying it's different. In an academic environment, you can always, you work with an advisor that knows more about this stuff and point you in good directions, often. They point you in bad directions too, right? So let's be honest. But the burden on you is if you have a PhD level, you're looked at helping guiding where things are going. And you might not have the specific content knowledge of knowing about, say, fashion or ad tech, but you know what data does and that speaks, and you have to, push and guide that direction. So you have to be part of that conversation. You just can't take it, okay? You're not going to provide that guidance, and that's what I'm trying to say. Whereas I think the real focus I'm doing is this notion of how to fail an interview with me, right, is this notion of talking up versus talking down. There's lots of people like postdocs and people that have done some really great research, but they're used to talking to experts. They're going to conferences, they're talking to people that know what they're talking about, they use buzzwords and things that are not explained. That's not what you do as a data, that's what I did as a data scientist, not what our company needed, right, the fit. And so they're used to talking up to people that know as much or more than them, which really what you're used to, what I would say doing is talking down, not in a condescending sense, but you have to talk to people that don't understand the basics of statistics or computational methods, and you have to convince them that this methodology is what we should do, and this question that you really want to address is not tractable with our data, right? And you have to make that clear argument. So it's a communication thing, right? And it's also a bit of a self-learning thing that I think any PhD should have, is that at some point you have to inform yourself on what the right decisions are. And it might not be the best information, but we need a business decision by the end of the week. Done, okay? So you're going to do the best you can to move forward. So you have to be kind of okay with that and kind of move forward. Make sense? Good. So real quick on the why. For me, they were both very different things. TrueFit was an amazing opportunity, a $2 trillion industry for footwear and apparel. This was a 800-pound gorilla of startups and what's known as fit personalization. If you want to talk about what this was doing and why this is interesting. But $2 trillion industry is huge. This is bigger than advertising, all right? This is all the retail. This is bigger than movies. This is bigger than gaming industry. This is one of the most massive things. The online penetration is tiny. Okay? As in, like, most people that buy still goes to stores and brick and mortar and everything else. So the opportunity to impact this is huge. You're not competing with a whole bunch of things. So if this took off, this is a huge golden egg. And it's still doing well, by the way. But the other thing, it was very deep data. So from a data jockey or data monkey, that like what I wanted to do, it was very interesting to me because you were trying to solve this problem with some other data, but they had the deepest data. They had probably 10 years of experience, because the people came out of fashion, of developing these things to understand how specs are made and forming this kind of database of what's going on. We were talking about this in Vanderbilt has this great, genetics and biomedical database. That was very deep data. So the quality of data that you're working on, for me, was very exciting, because that's what I wanted to do. I didn't want to come up with things to gloss over data. I wanted to use data to inform real things. So I thought there was a great opportunity. It was a growing team. It was a startup. I already talked about that culture. And they were working on what I think are difficult problems. So at Rubicon Project, I really liked the people, okay? It was a leaner startup, but it was bought by Rubicon Project with a publicly traded company. So I was like, oh no, but it's a turnaround company. So it felt like a startup, right? We are losing money, all right? So that to me is exciting because, they had changed the C-level. They were kind of doing things. We actually made a decision to piss away $40 million of revenue. This is all public, right? But piss away $40 million of revenue. That made our stock price go from $5 to $2, right? Shareholders didn't really like that. But what it did was increase transparency and try and change actually the system. And so that kind of buy-in from the management levels was one key aspect, because at TrueFit, one of the things that I was trying to do is actually get the impact, right? And I felt I couldn't make the impact I wanted to. And I felt that here it had that, right? There was real-time optimization, very different data, different domain, advertising technology rather than making clothes fit better. And this is the point that I felt I could make a larger personal impact, all right? And so that's why. So if you are staying in science, why should you care? This is just the nice little slide of like, do I really care about this? Do I have to go in industry? I say you want to care at this point, right? You might transition yourself even if you really want to do a postdoc or you want to continue, right? You know people that will transition. The number of astronomers in data science working at places, at Stitch Fix, anywhere in Silicon Valley is huge, okay? I'm sure in biophysics, medical physics, all of these things, that's true. You might contract in the future. There might be occasions where someone like, I want your expertise on this stuff, because you might have that. This has happened to some people that are very well known in data science fields. They had no expertise, but they had a blog of a whole bunch of links, and then the White House called them and said, hey, what can you inform the president about this, right? That happens. So maybe not on that scale anymore, but the thing is like, there are going to be people that ask you certain questions, and maybe there's a nice thing that spins off. You might advise people that do. If you're a professor here or whatever else, you're going to advise people that want to go into something else, right? Funding astronomy is not a happy story right now, okay? So some of your students, you might want to fund students, you might want to give them some padding if they're going to commit to this. Can you build some some tools that are useful? How about your tools? Who here uses open source tools in anything that they do? Hey, look around. Do you know if we were at a tech conference, do you know how many hands would be up? Everybody. So somewhere around 2013-ish, it shifted from proprietary tools being the dominant thing everywhere else to the overall numbers of open source tools doing that. So both industry and academia are actually using the same tools, right? The Python conferences, other things else. They're using the same things to realize this. So if someone builds something, or if a company supports a few staff members to improve things, it's better, right? And so you're using the same tools, so we're now having communities that are overlapping in their kind of tools. How about funding? Anyone know how this can impact things? Who thinks that a startup is economically viable? Good, good. They're not. Does anyone know what the funding cycle is for things? Series A, Series B, Series C, these are successive series of funding.
3 to 5 years on the first series.
Yeah, something like that.
About a decade at the best. Next round, if you can survive.
Yeah, exactly. At what stage in these series are they looked at to actually make money?
That depends. That depends on the structure that you've gotten into it.
It's true, it very much depends, but typically not until series, right? So you've now gone through about a decade, at least, of fundraising millions of dollars, okay, before you're ever looked at turning a profit. What you're doing is investing and growing. Uber, Lyft, they're not viable. They're still bleeding money, right? They're doing this and they're changing the business. What is this? This is, in one sense, again, my perspective, this is very much like academic research, right? You are using other people that are investing in your resources to bring something, right? They're investing in these things, most of which do not succeed, most of which fail. Venture capitalists have learned this, they analyze this, they can even make something that fails, money making, so that's a whole other thing. But how they're investing. Rich people are now, in astronomy has a history of only being done by rich people, and that's what kind of moved forward. It was like that funding structure is kind of changing. So how things are being funded, rich people are now investing in venture capitalists or new things. So it's like that could fundamentally be changing how we're doing a lot of this, how we're doing a lot of science, how we're doing a lot of health research. Pharmaceutical companies, how they're investing in R&D is like a common topic that comes up. It's being influenced by data, it's shifting. All of these things are shifting. So where do we place in that? Even if you stay in academia, these shifts are going to impact you. Universities too, but we won't get into that. So anyways, that's kind of the why of things. So hopefully you understand a little bit of what I say about data science and the how. I'm going to go through this kind of really briefly because I've interlaced a lot of the how. So how do you actually prepare for these interviews? If you want to do this, or how do you advise someone? Here you go. Here is all of these little things. Start Googling, start taking your online courses, go master all this. I would argue that's a really, really, really bad idea. All right, especially if you have a PhD, you're coming out this, there's a lot of hype of these things. Any one of those people have done PhDs on or done in-depth things. You can have machine learning experts, you can know these things. If you want to pretend that you spent 5 years doing your research on biostatistics and you can polish up and learn Python and R and Julia, I like Julia language by the way, Julia or any of these things, and you're going to become a viable contributor after spending 4 weeks of randomly doing these polishing up things, I'd argue that you're selling yourself in the wrong niche and you're setting yourself up to fail. You got real important skills. You need to figure out how general they are, where you know things, where you don't know things, and how to learn things that you don't know. Those are much more key. You need to be able to sell the point of your research, the point of what you're working on, or a point of method in 2 to 3 minutes to someone. You need to work on elevator pitches, right? I would say go to meetups, right? And talk to people that have no idea about what your field of study is and tell them what you're doing and why it's cool. That is a much better skill for interviews than having a knowledge of like, ooh, I did this deep neural net of stuff. You're like, well, why don't you do logistic regression? If you come up blank and comparing a neural net saying it was really cool to why logistic regression wasn't good, I'd say you'd fail a lot of interviews, right? Those kind of things, that in-depth, painful knowledge is really a lot of what you're trying to bring to the table. So it's very hard to gloss over when you're coming with a PhD level, right? So don't give in too much to the hype. I would argue that you just want to do first things first. Honestly, turn this into a research project and look at yourself, right? What do you like about science? What do you not like about it, right? What is appealing about data science to you? What do you want to do? What is your job description? You want to stare at computers and program? Do you want to communicate things with plots? Do you want to sell this to clients? What aspect of that? By the way, you'd think that, oh, if you're writing code, it's better. That's the software track. You get too close to that, that's something else. There's actually in data science, some people that do the visualizations and other thing command a higher salary, right? And it also speaks better to the board, you get better visibility, and you get less shoehorned, if you will, right? So those are the things to consider. What are you willing to give up? What's important to you, what's not? And then how realistic are your hopes? I want to found a startup and make millions of dollars, said lots of people, okay? It's really great to have an idea. To bring even a fantastic idea to fruition requires chance and so many other factors that are so beyond your control. So the real key that I want to sell here is ask yourself questions, forget about the hype, and try and network. Network to get real experience from people. Talk to people, email people, do weird LinkedIn connections, randomly email and do that. Make use of people that are bolder than you if that's not your thing. In one of my interviews, I was telling Andreas this earlier, in one of my interviews I was going, they're like, well, I like you, we'd normally have you in, but we have someone else in, it looks like they're ahead of you in the process and we're probably going to extend them an offer, right? I'll contact you, but it's so he's basically telling me, no, you've done so well in that. So I said, fine, do you have half an hour to go over what things went well and not? I'd done a data challenge, I had him critique my resume, I had him give me feedback of what did you like about this, what did I miss? And he gave me very specific examples that made it better for me. Right? That made my process better, that I learned from. Because I turned it into, well, this is a learning, what can I get out of that? That kind of networking, that kind of knowledge is really hard. So, in my cases, how did that, in my specific how, and I'll try and wrap up in the next couple minutes in case we have questions. At TrueFit, I was hired by a former astronomer, so he knew my skills better than I did, fantastic. Overlapped with my research experience. What they wanted me to do was actually incredibly similar. I felt I could impact a team, right? I chose skills that aligned with that, and it was a focus on communication, which I thought was all key aspects that I thought was useful, right? In the Untitled Project, right, I had a very good insider. Turns out some astronomer that I helped get into data science before I switched, right? She went there. She was actually hired at Untitled before I was. She was there for a month and a half or something, and then called me up and goes, look, I'm quitting, but I think you'd be a better fit here. I'm like, if you're quitting, why would I want this job? What she did is gave me a very good insider job of working there for a month or a half or 2 months of what the company was doing, why she thought it was a better fit, and what was going on. Because I helped her in the past and we communicated, she recommended me for this other job, I got the insider track. It was a small company. The people that wanted to move forward were stuck on their visions, they weren't describing what you're going to do on a day-to-day basis. I stayed there because I knew what I was getting into, and I knew beyond the job description, right? So I had more knowledge of what I was really going to be doing and a really good insider track. You can't buy that kind of information. So I also knew from my experience what to emphasize from previous, what I wanted in a different environment, and also a better sense of my worth, right? Didn't help also in networking, you can also talk salaries. Any data scientist of a PhD level that's getting a job, you should know if you're paid market value, above or below. You should know what your equity is. Not exactly, but you should know whether that's reasonable or not. And if you don't know that, you should be able to find that out pretty shortly. All right? It's not this business side of like, we don't know what you're worth. If a company is offering you way below your worth, you better understand why that is, or you better not, or they're not going to value you, right? Because that means they don't value you in the organization. Maybe they're cash strapped and it's a nonprofit or something like that. That's reasonable. That's your choice. But figuring out the answer to those situations is what you should do. I was also more willing to take risks than Toggle. It was a 20-ish person company. I joined in December. They had funding through February, right? But there was a core group of people that had worked at several places together, and so I was willing to take that risk. It was an educated guess moving forward. They found funding, not as much funding as they wanted, but then they were acquired, so they did fine, right? But that doesn't always happen, right? So you have to kind of know what's going forward. So how to prepare? I would argue that the biggest thing that you want to look for is a fit. Align what you like to do and what you think you want to do and an environment that you think is successful with what the company needs. And that's not a given. If you randomly apply everywhere, you're not going to find that. Actually, I would argue that no one should do that at the PhD level, right? You should not randomly apply online at all. Okay, there's very good reasons for that. We can talk about that as a separate thing and move forward. But you should inform yourself and get inside tracks because people don't know what's going on, and you actually eliminate a lot of things that can help you get a job. A lot of companies actually even don't look at the online applications. They'll look at them for software engineers, but a lot of companies actually don't look if you just randomly apply online. They're not like postdoc applications or things like that. It's a very different field. So focusing on the unicorns, right? By that, these mythical things. We're not all Texas Rangers. It's not a data scientist go in there going to solve all their problems. If you focus on that, there are some people that can do that and do that. But it's just not tenable to think about that as the model of where you want to go with things. But does anyone know any history of the Wild West and gunslingers? Obviously, everyone's seen the movies and stuff. Anyone know any real history of them? Just kind of curious. It's kind of interesting because there's all this talk about the Flash or the gunslingers and apparently most of them was all hype. Big shocker, right? I mean, most people weren't in gunfights. Most of them didn't kill a whole bunch of people. There was bad stuff that happened, but most people were like shot in the back and everything else. There's only a few cases of documented where people have really done it. One of the people is Wyatt Earp, right? And Wyatt Earp apparently was never shot, but he was in the OK Corral and everything else. But he's quoted as saying, right, you need to learn to take your time in a gunfight, right? That's one of the quotes that he has. And like, what does that mean? You're in a gunfight, you're in a battle. What do you mean take your time? That sounds asinine, right? Sorry, you might have to edit that out. But anyways, here's the more expanded quote. I'm just going to read it because everyone else is anyhow. When I say that I learned to take my time in a gunfight, I do not wish to be misunderstood. For the time to be taken was only that of a split fraction of a second. That means the difference between a deadly accuracy with a 6-gun and a miss. It's hard to make this clear to a man who has never been in a gunfight. Perhaps I can best describe such a time taking as going into action with the greatest speed of which a man's muscles are capable, but mentally unflustered by any urge to hurry or the need for complicated nervous and muscular actions, which trick shooting involves. So mentally deliberate, but as muscularly fast as you can move. I think the parallel to data science is huge. People are like, we want these answers now. Figuring out what you can address and taking the time to address that correctly is the key skill that you're often bringing, all right? You're like, sorry, I'm not going to have that by the end of the day. I can have this approximation, or I can guide it. Maybe that's what you have to go with because you need an answer by the end of the day. But understanding where you can be and what you can be and taking the time to get there is great. But I don't mean go and wait 4 months later and come up with the right answer to a question now that your business is up. You know. So I think there is some analogy to this thing. It's not a lone gunman, but you do have to figure out what you're doing and move appropriately. So this is just a basic thing. There's lots of different things of data science. Whether you want to stay in science, whether you want to do any of these other things, they're related. And then go into finance, tech, the half dark side or whatnot. And then that is where I'm at. So I can leave this up here, but that's basically where things are. Go ahead.
Can you say something about how people who hire in companies see PhDs differently from masters or undergrads, and whether PhDs are valued or not valued? How does that work?
Well, I would say postdoc. If you're thinking of doing a postdoc and that's an advanced thing, that's not very valued. So I had 7 years of postdoctoral work, and I was competing with people who just got a PhD. And from industry side, they're like, "Oh, you just finished up." I was like, I just finished up a while ago. So I'd say postdoctoral work is not a whole lot of bang for your buck. I think a PhD, you're looking to lead. But even a PhD, you can be hired as a junior data scientist or a senior data scientist. So it's your skills that differentiate. So a junior data scientist might be a master's level, might be a PhD level. It's really what are you bringing to that team? And what can you demonstrate? It's not what your end capability is. It's what are you showing that you can move forward. A lot of it is the intangible skills. If you think that you're going to get a senior position because you can run deep learning or know how to do TensorFlow or Keras or whatever else, you got another thing coming, right? That's usually not the case. Is that helpful? So with a PhD level, what I would be looking for and what our team was is someone that can help guide things and they independently kind of guide their research. Right? So a lot of things that you learn towards the end of your PhD or like in a postdoctoral, like can I guide this successfully?
You said you had a lot of experience with other astronomers, and this is I'm coming from like a chemistry background. Do you have any don't necessarily have a lot of experience with like large data sets.
Yep. So there's plenty of things that you can do. A lot of the methods, when people talk about big data, it's one of these notions that's like, it's not really big data, right? Like I went to a big data company, I won't gonna mention which or where, but like the entire production system and a fair amount of the data fed to my laptop and we can model it. So, you know, what does that really mean by big data? So I think you just have to know what your limitations are and what skills they are, and you can sell it as such. For example, Rubicon Project just hired a computational chemist on the data science team, right? And she did some very crude fitting, whatever else. But we loved the interview and what she did with it because she was very clear of the limitations. She said, this isn't the best approach, but this is why I did it. And it seemed to make sense and explain things well. And that was absolutely fantastic. And that's what we needed for the fit going forward. So I think there's plenty of that niche. It's really just applying the scientific rigor of how you tested it, how you move forward, and not necessarily the skills. In the roles that I've done, just to be clear, in a lot of data science roles, you're not looked at to create the scalable solution. That has to be really big data, right? You're supposed to know some little bits and bring the statistics and a little bit of the modeling and prototyping to it. So you have other support people that can do that for you. Does that answer your question?
Yeah.
Good. Please?
You talked about like the impact that you can have at these smaller companies. They have more impact, more money, and smaller number of people. I guess you can have an impact.
Mm-hmm.
How much do those companies is the emphasis on the
Thank you, by the way. Feel free to leave if you need to.
versus on actually like improving people's lives? So with like ads, we know most of us hate ads, I guess. But how much of that is in the companies?
Is in the companies.
Is there any discussion about the people, if you're in it for, you know, kind of helping out humanity, is there any of that in the companies, or is it really all about the shareholders?
No, I mean, it varies a lot in the culture. You'll find it everywhere, right? You can work with academic people that are like, we're really focused on the publication, or some people are like, well, we just want you to have a good career and do some good work throughout that. So I think you have that same type of variation in the companies. I pick companies that, for example, I have a family and I want that to be supported. So I wasn't looking as a cog for the shareholders. While I'm an expensive resource, it was family first, right? Some things want to do the right thing. All right, the company Rubicon Project, they were trying to stay alive, but they want to do the right thing by the community, right? About ad tech. They're trying to help advance it and bring it to the next level, right? At the sake of cost. So they literally gave away $40 million to try and both angle their position, but do the right thing for the community. So there is a little bit of this altruistic sense of what's better for everyone. And that exists more in tech than maybe many others. For example, things that they matter. At the startup that was very lean, where we had 3 months of funding when I started, right? They did a project where they contributed back, where they would have something where they give back to the community, where they go work or do something like that. Like this is them just pissing away money that they have to try and give back to like the local environment and do things like just give back for food or food serving or cleaning up things. And so that kind of sense also translates into the business. Does that make sense? Not all cases are like that, but there's a lot of support for these type of things, I think, generally in technology. So, was there another question?
So when that slide with Obi-Wan or whatever, when you're talking about like the kind of shotgun approach people take to like learning all these things, that kind of made my stomach drop a little bit because like, oh god, that's what I've been doing for the last like 2 months. But, so I guess my question to you is, I mean, my background specifically is a high energy theorist, so I do a lot of pen and paper stuff. I do a lot of blowing up on computational stuff. What's the best use of your time in terms of getting ready to like, do jobs like this?
Well, that's not an easy question, which is why I was trying to paint. It really depends on what your skills you'd like to do and what you want to find in these things and what companies you want to work for, right? So finding out what those are and what opportunities exist is probably the best use of your time. Then figure out what skills you have that are marketable and which ones aren't, right? So for example, in astronomy, I can program in Fortran. Great skill, not one you really want to sell. You might want to go, sorry. If you do nuclear physics, however, there is some applied Fortran where they have long code bases. And COBOL too. You can make a lot of money programming in COBOL still, because they don't have programmers that program in COBOL. Yeah, exactly. They literally, that's no joke, that's what's happening. The systems are outliving the people that designed it. Those are tongue-in-cheek, but I hope they're emphasizing the point that there isn't one right answer, all right? Learning about the fit of what you can do, I'm good at making plots. I've worked with pen and data scientists. There's one that his major contribution was writing Word document white papers. Okay, he wrote some Scala. It's not used in production. He likes single variable, names and things like that. Single character variable names. Sorry, which the engineers just loved. And then I taught him how to use Unicode in Scala and Julia, and so he could use Chinese characters, and he was very happy. The point is that there is a place for all of them. There's less pen and paper theorists that work there, but it was like, what is the modeling that you do? What is the niche that you do, and how do I sell that? You can worry about advancing that later. You want to polish things up for an interview, but that's not what's going to make the impact moving forward. And aligning to what makes the impact later is really going to impact your career a lot more than nailing an interview. That's what I was trying to emphasize. That makes sense? I can talk more after email or whatever else too. We're kind of done on time. So if anyone else wants more pizza to talk, I can stick around for a little bit. But I mean, in this setting, should we wrap that up?
Yeah, thank you again.
Thank you for having me. One small thing, I'm not a huge fan of